Welcome to this video. Today we'll talk about how to develop a pressure function for the top surface of this tank. And we can start off with the original expression that we were using in our last video here. And let's go ahead and see what we can do with this. First off, we have zero radius to whatever radius the tank goes out to, and that's our variable here. And we are going to have to do an integral to get the area under the curve of pressure that will give us the force that is being pushed on the top of the tank. So to do this, we're going to have to convert to polar units as well. This will give me from 0 to 2 pi, saying I want to integrate all the way around the face of the tank. And then I go from 0 to d over 2, saying, and I'm going to integrate not only all the way around, but whatever the radius is. I want to integrate all that. And then I put my function in. C times rho naught minus r squared over d squared. Rho naught again, because that was distributed to the gamma power. And then for my differentials, I say r dr d theta. First thing, I like to simplify as much as I can. There is nothing in here related to theta or anything to do with pi, so I know that I'm going to pull a 2 pi out instead of having to integrate. So my first thing is I'm going to say 2 pi and pull it right out. Second thing, c is constant, rho naught is constant, and I can say rho naught to the gamma power so that I can officially pull that out. Then I can say times the integral from 0 to d over 2 times 1 minus r squared over d squared to the gamma power, and r dr. We lost our d theta because there was no theta variable and we multiplied by 2 pi. Now, what can I do? This looks like a pretty nice u substitution to me. So I can say u equals 1 minus r squared over d squared, and I can say du equals negative 2 r over d squared du, and that simplifies to negative d squared over 2 du equals r dr. And hey, that's great. I've got an r dr right here. So giving myself a little bit of room, this can simplify to negative d squared pi c rho naught to the gamma times the integral from 0 to d over 2 of u to the gamma du. So what have I got? I'm going to say negative d squared pi should be negative 2 d squared pi c rho naught to the gamma times u to the gamma plus 1 over gamma plus 1 from 0 to d over 2. Made a little mistake here. That shouldn't be negative 2d squared because my differential was 1/2, and so that canceled out. So it is negative d squared. I will factor back in my u and say negative d squared pi c rho naught to the gamma times 1 minus r squared over d squared from 0 to d over 2. And I'll move my gamma plus 1 here because it's being multiplied. Finally, plugging in, we know that when we plug in 0 to this, it just becomes 0. So we can simplify this to negative d squared pi c rho naught to the gamma over gamma plus 1 times 1 minus d over 2 squared divided by d squared, and that will be our application for pressure on the face of the tank. Thank you for watching. Please remember to subscribe, and see you next time.